All right, so let's verify the thin lens law. We took some data and let's just make sure it works. So we have the thin lens law in front of us, where O is the object distance and I is the image distance. So I'm going to show you how to do just one of the calculations. What we're going to do is see if the left-hand side is equal to the right-hand side. So the left-hand side is equal to 1 over f. And in this case, we're using a lens with a focal length of 7.5 centimeters. So you just divide by 7.5 centimeters, and we get 0.133. And what are the units? 1 over centimeter. So make sure you don't get the units wrong on this one. So let's actually see, move down a little bit, what the right-hand side is equal to. So the right-hand side of the equation is 1 over O plus 1 over I. So for our first trial, look up what O and I is. O was 11 centimeters, and I was 21.3. So what you want to do is also calculate that. So just calculate this right-hand side and compare it with the 1 over f. They should be really, really, really close to each other. And again, you find a percent. In this case, it would be percent error, because 7.5 is the actual focal length of the lens. So you're seeing how close you got to 0.1113, 1 over centimeters for your O and the object distance, the image and the object distance. So the other thing we want to do is find the magnifications. So the magnification, you can find two different ways. You can measure it by, we measured the height of the image and divided by the height of the object. That's one of the ways we can find magnification. And in the first trial, the height of the image was 3.7 centimeters. The height of the object was 1.9 centimeters. So you can go ahead and calculate that. Then you can compare it with the other way to measure magnification, because remember, geometrical optics is a matter of looking at similar triangles. So you have all these similar triangles, and h over I is equal to the image distance over object distance if you go and look at all the triangles that we have put in the lens system. So the image distance over the object distance. So again, image 21.3 centimeters, object is 11. So then you go ahead and calculate. Then you can compare these two. In this case, you have to do percent difference. The reason why we do percent difference in this case is because both of these, or all of these things, are measured values. So you take the difference of the two magnifications and you divide by the average values. Okay? All right, well, that's it. And on to exercise number 3.